Hello, everyone, and welcome to another OGT session. We're going to be talking about energy today, which is an important concept to know for the science OGT. So you're probably thinking to yourself, this is going to be really boring, and you're probably right. But I'm going to try to do my best to make it as painless as possible and keep this as short as possible. This is heavy on vocabulary today, so make sure you're taking notes and you are making flashcards with this important vocabulary. Most of these things that I'm going to show you today are actually pretty easy, and the words seem big and the words might seem intimidating, but the truth is they're pretty easy concepts. So you've probably never really thought about energy before, and that's okay because other people have. And so there's a lot that goes behind energy, and it is obviously a really important part of just our existence. And so we're going to just talk very briefly about things. There's a lot of math behind all of these things, but we don't need to know any of that. We just need to know some really fundamental concepts. I'm going to start with two types of energy, the two main broad categories of energy that seem like such intimidating words, and they're totally not. That is kinetic energy and potential energy, which is literally to move or not to move. Kinetic energy is anything in motion that can be as small as an atom to as big as a moving star spinning through the universe. Kinetic energy is just motion. Potential energy is not in motion. However, how much potential energy will something have once it is in motion? And I'll explain a little bit more about that. So, kinetic energy, let's talk about it for a minute. As I said, it's anything in motion. So you have the rubber band here and you flick it across the room as it's flying across the room. Guess what? That's kinetic energy. On a roller coaster going up and down, you're using kinetic energy. And then pushing a ball down the hill, kinetic energy. You walking down the sidewalk, kinetic energy. Me moving my hands, kinetic energy. Anything in motion is kinetic energy. Potential energy, not to move, right? So you're not in motion, but how fast are you going to move once you are in motion? And there's a big math behind that, which is velocity and mass. How fast something is going, or how potentially fast it can go, how steep is that incline, and how much is the mass, right? So we have a ball here on top of a ramp / pyramid. How the potential energy is right here at the very top of this ramp. The potential energy is the greatest. Why? Because it's at the very top. So once it actually is rolling down the hill, this is the fastest it's going to go right here at the very, very top down that incline, if that makes sense. Okay. So some OGT questions to consider. So this is how I've seen these two concepts asked about on the OGT. Where is potential energy the greatest? Remember, it's at the very top. So the top of a hill, like pretend like you're going sledding, right? You're at the top of the hill. Your potential energy is right before you take off down the hill. Once you start moving down the hill, you're using kinetic energy. When is kinetic energy the greatest? Well, let's go back to the sledding analogy, right? You're at the top of the hill. You're going down top of the hill, greatest potential. You're sliding down. Your greatest kinetic energy is right there at the very bottom of the hill, right? Because you've gained speed. You're gaining speed as you go down. It's very greatest. The fastest you're going to go right there at the bottom. What happens as you go uphill? What happens to kinetic and potential energy? Well, think about it. As you're moving up the hill, your potential energy grows, right? So if you're walking up a hill, you stop right here. Your potential energy is from here to here. You walk up a little more, your potential energy is from here to here. As you go up the hill, your potential energy grows, right? As you go down the hill, your kinetic energy grows. but you lose potential energy, right? Because as you're going down, let's say you're at here, here's where your potential energy is the greatest. You start to move down, you stop right here. Guess what? Your potential energy is now from here to here, right? So it decreases. Potential energy decreases as kinetic energy increases. Write that down. Okay, so I talked about what happens when you go downhill. Okay, so kinetic energy versus potential energy. She's on the swing here. As she's going back, that's her kinetic energy, right? Her potential energy is the greatest right here, where she's up at the highest just before she goes down. That's her potential energy. Her potential energy is actually in motion. Okay, here again we have a car. Potential energy. This car is once it's here, the potential energy is the greatest at the top of the hill. As it moves down, kinetic energy is the greatest right here, right? Because it's had all this time to gain momentum. So it's going to be the fastest right here. As we move up, the potential energy grows, right? Right? Growing up here, it's the highest. As we go down, the kinetic energy grows. So potential energy, like think of a rubber band, you're holding a rubber band, right? The potential energy is as you're holding it. Once you let it go, it uses kinetic energy to snap. So I'm going to do this as the last time I'm going to talk about it, okay? I just want you to remember this because it seems so complicated and it's so not, right? So kinetic energy is kinetic energy in, meaning that you're gaining potential energy as you're going up the hill. Potential energy is greatest here. Losing potential energy as you go down, but gaining kinetic energy, and it's the greatest right there. So you might see a question like that on the OGT, and just understand those concepts, write it down, draw a graph, if you will, and then yeah, that's all you need to know about kinetic and potential energy. Sometimes you'll see potential energy. It'll be called gravitational potential energy. Same thing. It's just how hard is gravity going to work on that, okay? We're going to talk about now energy types, okay? So, and there are several. But the OGT predictably only asks usually about the ones I have listed here. So that's what we're going to go over. Make your life easy and replace anytime you see thermal energy or the word thermal, go ahead and replace that with the word heat, because it's going to make your life easier. It'll make it so much easier to read, right? So, for example, there's a question like a girl steps out on the sand. How is thermal energy being transferred? And if you say, how is heat being transferred to her feet, makes it a little easier to figure out. And we're going to talk about that actually in another video, probably the vocabulary video. So chemical energy is exactly what it sounds like. It's chemicals, right? Chemical energy being released by chemicals. Now, this includes something like food, because food is technically chemical energy, right? Gasoline, batteries. Chemical energy, electrical energy, electrical things, lightning, a light bulb, electricity, right? Mechanical, they have a real complicated definition here. Objects have mechanical energy if they are in motion or if they're at the same position relative to a zero potential energy position. Sounds really complicated, but I really want you to think about mechanical energy as machines, right? So like a drilling into wood, that's mechanical energy. A car, mechanical energy. Just think of that as machines. And most of these are very intuitive, right? You can figure these out if you just stop a minute to think about it. So when you see the words on the OGT, just slow down a second and be like, what is a drill? Is a drill, what kind of energy is that? It's going to be mechanical, right? So nuclear energy, I haven't actually seen this on the OGT. I just slapped it on here just in case. It comes from splitting atoms in a reactor to heat water into steam, turn a turbine, or generate electricity. Some examples, okay? Nuclear energy, we have fusion in stars. Light, we have electrical energy here in this light bulb. Technically, this is also chemical energy because of the chemical transactions going here inside the batteries, right? Magnetic energy we didn't go over, but I think that's pretty intuitive. Chemical energy, you have a beaker here with some kind of chemical. That's chemical energy. Thermal energy, remember I said replace it with heat. And then we have kinetic energy, is actually this apple in motion dropping from the tree, and potential energy is just this apple just sitting there before it falls. And that's really all I've got for this first initial energy video. I hope it wasn't too boring, but I will do like another vocabulary video that'll go into like how energy is transferred. There's only 3 things you need to know for that, but we'll get on that. And I hope that you have a great day. We'll talk to you soon.